Hello guys, welcome to today's online tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do press subscribe button and notification bell. That's our update on this YouTube channel. Thank you and God bless you. Amen. Now today I'm going to consider what 2022 YDC Chemistry Practical. 2022 YDC Chemistry what? Practical. And we're talking about what? Chemistry Practical. We are going to do what? We are going to be answering what? 3 questions under Chemistry Practical. Now, the first practical is volumetric analysis, the second practical is qualitative analysis, and the third practical is general knowledge about what? About chemistry. Now, I've done tutorial on what? Volumetric what? Analysis. I've said one of the questions that you might likely to meet on question number 1, which is volumetric what? Analysis. And this is basically on what? Qualitative analysis. So we are going to be considering what? The second part of the questions in chemistry practical, which is qualitative analysis. Here you are going to be asked questions on how to test for some cations and anions in a given salt. How you can test for anions and cations in a given salt, and in some cases they may ask you to what? To detect or confirm a particular what? Gases. And here is a question before us. E is a mixture of 2 inorganic salts. E is a mixture of 2 inorganic salts. Note that the following tests were carried out on E. Complete the following table. Now, we are told that what? E is a mixture of 2 inorganic salts. That is, E contains 2 salts, and these 2 salts are inorganic. And the following experiments were carried out to know what E is made of. Now, we have the test column, we have the observation column, and the inference what? Column. Now, the first thing that was carried out here is that E plus the seawater, that is, E was added into a test tube, and water was added to what? To E. Now, when they stir it, they have partly soluble solution. Partly soluble what? Solution. Whenever you have partly soluble solution, meaning that you are going to have filtrates and what? And residue. Something like this. The filtrates will stay on top, while the residue is like a solid. Now, the filtrate will be on the top, while the what? The residue will be what? Below. Now, we are now told that the kind of filtrate we have here is colorless filtrate. It has no color. Now, while the residue that we have here is what? Is blue-green. So, if I want to write my inference based on what was observed here, I'm going to say, okay, because this is partly soluble now, salt what? Salt E is a mixture of soluble and insoluble salt. It's a mixture of soluble and insoluble salt, because we are told that it's partly soluble. So, E is a mixture of soluble and insoluble salt. Now, the soluble salt will be colorless, will be the one that will give us colorless filtrate, while the insoluble salt is the one that gives us blue-green residue, because this is going to be filtered, and when you filter this, using what? Filtered paper and funnel, the residue will stay on the what? On the top of the what? Filter paper, while the filtrate will come down. So now the filtrate part of it is the soluble salt, and the residue part of it is insoluble what? Salt. So that's that about what? About that. But look at this now. What are the things that we can what? Get from this blue-green residue? What salts or what kind of salt have blue and green residue? Now, we are going to look at it very well. We have copper and iron. Look at this. Copper and iron are transition elements, and all transition elements have specific color. They have specific color that they have. Now, look at this. Copper is blue in color, while iron 2 is green, while iron 3 is what? Is dirty green or brown. So now When you're having blue here, it means that you can either have copper or we have what? Iron. So here we can say, okay, Cu2 plus slash what? Iron 2 plus present. Now, because we have blue-green residue, we can say, okay, either copper, which is blue in color, or iron 2 plus is what? Is present. It's present. So, copper 2 plus or iron 2 plus present. So, that's that about what? About question A, Roman figure 1. Roman figure 2 now, that's a residue plus heat. The residue was collected with a boiling what? With a boiling tube now in the laboratory, and that residue was heated. It was heated with what? With Bunsen burner, and we are told that evolution of a colorless what? Odorless gas occur. Evolution of a colorless, odorless gas occur, and that gas turn like water milky. Evolution of the colorless, odorless gas, and that gas turns lime water milky. There's only one gas that turns lime water milky, which is what? CO2. So in this place now we can say CO2, which is carbon what? Carbon 4 oxide. Carbon 4 oxide is CO2 from what? From CO3 2 minus. Now this gas is obtained from what? Anion CO3 2 minus, which is called what? Which is called carbonate ion. So CO2 from CO3 2 minus confirmed. Why is it confirmed? Because the only gas that turns lime water milky is what? Is CO2. So that is the confirmatory test for what? Carbon 4 oxide. So CO2 from CO3 2 minus confirmed. So that's that about what? A Roman figure 2. Now this third one here, which is Roman figure 3, residue plus HNO3. Residue plus HNO3, we can see vigorous what? Effervescence. Effervescence is a solution whereby we see a what? When you add acid to a particular what? A particular solution, and there's a kind of bubble coming out. There's a kind of bubble. So that's what we call what? Vigorous effervescence. Something like it's forming foam. That's what we call what? And that vigorous effervescence will completely what? Will completely result to a what? A dissolved what? Solution. So whenever you have a what? A vigorous effervescence, then that indicates that a gas is what? Is present. A gas evolved. A gas is given up to the what? Atmosphere. That's why we have vigorous what? Effervescence. Then which of the gas is being given up? Now look at this. Gas turns lime water milky. So if there's a gas being given up here now, and that gas is turning lime water milky, we need that we are still having what? CO2. So we have CO2 from what? From CO3 2 minus confirmed as well. So whenever you see lime water turn milky, it is what? CO2. So these two tests is used to confirm what? That CO2 is present in this one of this one salts. So now the next one is what? Is portion of the resulting solution. Now, portion of the resulting solution, meaning that after this what? This HNO3 has been added to residue, I told you that there will be vigorous what? Effervescence, and then that effervescence, after the complete effervescence has occurred, it will turn that solution to what? To what? It will turn that what? This residue into solution. That is, it will dissolve the residue, and that solution now is now brought here now. That solution that was dissolved as a result of what? Adding HNO3 was now brought down here, and that portion of the resulting solution from what? From A1 now plus ammonia, aqueous ammonia. Now the resulting solution that has dissolved as a result of HNO3 being added to it now brought down here. A portion of it is brought down here, and then they add what? Ammonia, aqueous ammonia in drops. Whenever you add aqueous ammonia in a solution and we have blue gelatinous precipitate, then that signifies that there is copper there. Whenever you add ammonia in a portion of a solution and you have blue precipitate, that shows that copper 2 ion is present, because copper 2 ion has a characteristic color of what? Of blue. So when I say blue gelatinous precipitate, you can say that Cu2 plus present. So that's that. Now in drops, so we have blue gelatinous precipitate, so Cu2 plus present. Now in Sx, whenever you add ammonia to a what? To a solution containing what? Copper. Whenever you add ammonia to a solution containing what? Copper in excess. Now, whenever you add ammonia in excess to a solution containing copper, that blue precipitate here will turn to a deep blue in excess what? Ammonia, aqueous ammonia. So meaning that what? Deep blue, this blue gelatinous precipitate, when you add what? When you add more of ammonia what? Aqueous ammonia into that what? Solution, it becomes a deep blue solution. So meaning that this blue gelatinous precipitate becomes deep blue in presence of what? Essence and aqueous ammonia. So now I'm going to have what? The blue PPT now. The blue PPT dissolved to form a deep blue solution. A deep blue solution. So that's what is up here. Blue precipitate dissolved to form a deep blue solution. Please know that the what? The blue precipitate that was formed in drops will furtherly what? Dissolve to form deep blue in aqueous what? In aqueous ammonia, in excess aqueous ammonia, and that confirm copper 2 ion. Whenever the blue precipitate become deep blue in the presence of what? Excess aqueous ammonia, then we say Cu2 plus confirmed. Cu2 plus confirmed. Please know that that's one of the confirmatory tests of copper 2 ion in a solution. So when you add aqueous ammonia in excess to a copper solution, it becomes what? Deep blue. So Cu2 plus confirmed. When it becomes deep blue, then you said Cu2 plus is confirmed. So that's that about that. Now the portion here is what? Portion of the filtrate plus sodium hydroxide. Now the filtrate obtained with, now I told you that this is going to be what? Residue. And this one is going to be what? Filtrate. Now, portion of the filtrate now, plus sodium hydroxide in drops. Now, what do we have? We have white gelatinous what? Precipitate. You have white gelatinous precipitate. Now, whenever you add what? Sodium hydroxide to what? To a filtrate, and you add white gelatinous. Gelatinous means that an oily what? Something like an oily is seen on what? On the surface of the test tube. So that's what called gelatinous. Whenever you see that what? That oily substance along the what? Along the what? Test tube, around the test tube, we said it's gelatinous. So why gelatinous precipitate? Now there are two ions that can be gelatinous in nature. We have what? Zinc ion and aluminum ion. These are the two likely what? Likely cation that has the characteristics of white gelatinous what? Precipitate. Also sometimes we can have PB. So some people might include PB, you will not penalize for it. But when I'm talking about what? Portion of filtrate plus sodium hydroxide in drops. White gelatinous precipitate, the only ions cation that are capable of forming white gelatinous precipitate with sodium hydroxide are zinc 2 plus and aluminium 3 plus. So please know that. So then in excess sodium hydroxide. Now when you add sodium hydroxide to a solution or to a filtrate and you have white gelatinous precipitate and you now add that what? Sodium hydroxide in excess, then the precipitate soluble, then what are we going to have? So when you add sodium hydroxide in excess, what are we going to have? We are doing that what? This precipitates dissolve. This precipitate dissolve in essence what? Sodium hydroxide. And what are the likely what? Cation that can be found in this solution when they dissolve the sodium hydroxide? And these two cations, which is zinc 2 plus and aluminum 2 plus, are also soluble in sodium hydroxide. They are soluble in sodium hydroxide. They dissolve completely in excess what? Sodium hydroxide. So you can say zinc 2 plus and aluminum 3 plus. So these are the what? Cations that are likely to be found when the precipitate soluble in excess sodium what? Hydroxide. Please know that the two cations that are likely to form gelatinous, white gelatinous precipitate are what? Zinc 2 plus and aluminum 3 plus with sodium hydroxide, and they both dissolved in excess sodium hydroxide. That's right, zinc 2 plus and aluminum 3 plus. Now the question is yet to be completed, so let's clean this as we write the remaining part of the questions. Question number B, Roman code 2. Portion of the filtrate plus aqueous ammonia in drops, then in excess. Now look at this. We have already used sodium hydroxide, and we are able to get zinc and aluminum. But now here we are given portion of the filtrate plus aqueous ammonia in drops, then in excess, and we are told under inference that this zinc 2 plus confirmed. And look at this, in the first previous questions, we are told that when we use sodium hydroxide with the portion of the filtrate, we get zinc and aluminum. But in this case, zinc is confirmed with aqueous ammonia, because zinc ion dissolved in aqueous ammonia. It dissolved in aqueous ammonia. Please know that. Now what I'm going to write here, I'm going to say, okay, portion of the filtrate plus sodium aqueous ammonia in drops, you are going to see white gelatinous precipitate. White gelatinous precipitate. Why? Because we are told that zinc is confirmed here, and the characteristics of zinc, when you add ammonia, aqueous ammonia in drops, is going to give you white gelatinous precipitate. A solution containing ammonia, a solution containing zinc ion, when you add ammonia to it, you are going to see white gelatinous precipitate. An oily An oily white precipitate will be formed in drops of of sodium of ammonia, aqueous ammonia, in drops of aqueous ammonia. Then when you add aqueous ammonia in excess to a filtrate that contains zinc ion, then the white precipitate will dissolve. The white precipitate will dissolve to form a colorless solution. So white precipitate dissolve. You can say precipitate soluble. Precipitate soluble. So that's why zinc ion is confirmed, because the only ion that is soluble in ammonia, the only white precipitate ion that is soluble in in ammonia is zinc 2 plus. Is zinc 2 plus. Aluminum is insoluble in ammonia. So that's why here you can, when you say white gelatinous precipitate, you can only write you can write the zinc 2 plus and aluminum 3 plus. You can say when you have white gelatinous precipitate, you can say zinc 2 plus and aluminum 3 plus present, because you are not sure. You are not sure. But immediately when you add it in excess and precipitate soluble, know for sure that it is zinc 2 ion that is being confirmed. And that's how we test for zinc ion in a solution or in a filtrate. So that's that about zinc 2 plus. Now the last thing is portion of the filtrate plus barium nitrate. Plus barium nitrate solution plus dash. We are told that the white precipitate form. Now, the portion of the filtrate plus barium nitrate. We have to supply the missing the missing puzzle here. Now, white precipitate is formed. Now, the tendency, whenever you see portion of the filtrate adds with barium chloride, the barium chloride is just to prepare solution for an acid to be added to it. So you can add dilute, any dilute acid will work here. Dilute HNO3 and dilute HCl. Usually dilute HNO3 and dilute HCl. So let's go to dilute HNO3. When you add dilute HNO3 to the portion of nitrate and billion nitrates, you are going to have white precipitate. And this two solution is used to test for anion of a particular substance or sample. So when you add barium chloride or barium nitrate with what? With HNO3 inside the filtrate, then you are going to have tendency, you are going to have C2O minus, CTO3 2 minus, SO3 2 minus, SO4 2 minus, SO3 2 minus present. These are the what? Likely ion that can be what? That can be present. But we are told that the precipitate here remains insoluble in excess acid, that is in excess dilute HNO3. So the only anion that is insoluble in HNO3 is what? Is SO4 2 minus. So that is the only ion that is insoluble in excess of acid. So that is SO4 2 minus now is now confirmed. So that's that about that. So we can see that what? We have confirmed what? Some ions and cations, some ions in this one experiment. What are the ions that we have confirmed? Please, let's clean this. What are the confirmed ions in this what? In this exercise. Now, you have to write it out. The ion confirmed under cations and anions. Now, what are the ions that we confirmed under cations? What are the ions that we confirm under anions? Now, these anions, CO3 2 minus. The second anion that was obtained is SO4 2 minus. So these are the anions that were confirmed from the experiment. The CO3 2 minus from which CO2 evolved. CO3 2 minus from which was CO2 evolved, and CO4 2 minus that was confirmed with what? Dilute acid. And the other cations, what are the cations that were confirmed in this experiment? We have Cu2 plus, the blue precipitate, and what? And the white gelatinous precipitate, zinc 2 plus. So from here now, you can easily guess that the inorganic salt, zinc carbonate salt, will be soluble. And then what? This zinc carbonate salt will be what? Soluble. And then the insoluble salt will be what? Will be copper what? Copper sulfate or vice versa. It can be what? It can be because copper sulfate and what? So these are the likely what? These are the likely salt that we might have. Mixture of zinc carbonate and what? Copper sulfate. These are the what? This is the what? This is the salt that we can guess from the what? Anions and cations that we will obtain from the what? Experiment. So if you have not subscribed to this YouTube channel, please do press the subscribe button and notification bell. That's our update on this YouTube channel. Thank you for watching once again, and God bless you. Amen.